Hi, the project is about detection of pneumonia from chest X-ray. Before diving into the project, let us know about some of the basic things like what is pneumonia. Pneumonia is an infectious disease which can be caused by either a bacteria or a virus or a fungi. Now, this infection causes the inflammation of the air sacs in your lungs. The air sacs are called the alveoli in medical terms, and this alveoli, as you can see, is being filled with fluid or pus, which makes it difficult to breathe. Now, pneumonia can range from mild to severe, and severe pneumonia might cause death as well. So this can be detected using X-rays. Now before discussing how this can be detected using X-rays, let us see one X-ray image and the features of it. Like this is an X-ray image and you can see the lung area is black in color as air absorbs the least amount of radiation and thus it's black, whereas the bones around are white in color which absorbs the most amount of radiation. Now, how to detect whether a lung is pneumatic or not? As you can see on the left hand side, this is a normal lung and this is a pneumatic lung. So here, as you can see, all the distinction between the lung and the other parts, like this is the left heart, this is the right side of the heart, and this are the floor of the diaphragm. Whereas in the right hand side photo, this part is hazy. The lungs are not completely black, it's filled with fluid and thus it absorbs more amount of radiation than air, making it look hazy. So this is a clear demarcation between normal lung and a pneumatic lung. But there are some cases in which the infection might not be visible with naked eye. For example, this one. These two pictures almost look similar, whereas this is the normal one and this is the pneumatic one. But with naked eye, it's not very much possible to say whether this is the normal one or the pneumatic one, or for this the same as well. So for this, due to this reason, it becomes difficult for the doctors as well to determine whether the chest X-ray image is pneumatic or not. For that reason, we are doing this project, and also as we know, today's doctors say you to do all the tests before coming to them. So this is one way in which the patient can make sure whether he or she is having pneumonia or not. So this is a simple website in which the project has been deployed. This is the UI. Now by clicking on this button, the user can upload the chest X-ray image, and on prediction it would be a normal case like this one or a pneumatic case like this one. So the main aim of doing this project is to make life easier for the doctors and the patients as well. So it's very easy to use website and any layman can use this website irrespective of not having any medical background. So this is the reason of choosing this project. Thank you.
Now we are going to show you what the particular architecture of our model is, that is how we have used convolution neural network in order to separate between images, chest X-ray images from both the classes, that is pneumonia and normal, and how we have used that particular model in our Flask application in order to get the results. So first, let's see what we have done in our particular model. So instead of using our own hardware in order to train the model, we have used the Google Colab in order so that we can access high-end hardware, that is GPU and high RAM, without any hassle of without any limitations, right? So first, what we have done, we have saved our images in the drive. They are saved in a folder that is chest_X-ray, and then we are importing our drive in our Colab file. Then we have imported many libraries, that includes NumPy, Pandas, that are basic data analysis libraries, PyPlot for data visualization, CV2 for modification of images, that is image processing, CV2 is used for, that stands for computer vision, this library is usually used for image processing. Then these are the deep learning libraries that we have used in order to train our model. That is, we have used TensorFlow, and from TensorFlow we have imported Keras, and these are the various layers that we have used in our model. So we have imported them as well. These are the optimizers. This is the image data generator. I will be explaining what image data generator is doing in this particular model, and these are the callbacks, and I would be explaining them to you later. So these are the libraries that we have imported, and now we have noticed that in this particular data set the images are not present in the same amount, as in the number of pneumonia images, that is the chest x-ray scans of the number of the pneumonia is much more than the normal. So what happens if one of the classes has more data set, the more number of data set than the other class, it gets a biased training. Okay, suppose you are training them with more number of pneumonia cases. Since they are facing more pneumonia cases, they have a tendency to they can also learn that most of the cases would be pneumonia, and some of them would be normal. So in order to escape this, we have used image data generator. What image data generator does is that when we specify a batch size, it divides the number of images into two classes and gives them and in that particular batch it divides them equally and produces them as random outputs. So what happens in image data generator is that we can specify any data augmentation technique. We have to specify the batch size, and they would be an image data generator would be giving me results as in what the next batch of images would be, and that would be entirely random. Suppose if I run this suppose for next and each different iteration, I would be getting a new set of images that is different from the previous one. So let's just explain it through the code. I hope that it would be much more easier to explain it through the code. So this is my input path, and this is where my images are stored. So what does process underscore data does? Process underscore data takes an image underscore dims and batch size. What is batch size? Batch size is usually taken in order to prevent too much load on your hardware. So, and in order to promote efficient training of your data. If you are providing all the data set at once, it is becoming difficult for the machine, for the model to train itself. Instead, if you give it in batches, it will train with respect to batches, and it will be easier for and it will be faster for it to learn, as well as it would be more efficient for it to learn. And image underscore dims is basically the size of the images that we are taking. Since we cannot take random size images and we can train our model, since we have to provide the images in a consistent format, so we are taking image underscore dims. So now for image data generator and how it is helping in data augmentation. What is data augmentation? When we have less number of data, what we do is we can apply various augmentation techniques like zooming, flipping, rotating. The flipping can be horizontal, vertical. Then we can cut the images, and many such techniques that help us increase our data set so that the training is much more efficient and it is not biased. So this is the work of image data generator. So what are the things we are doing in this image data generator? So remember, this is the train underscore data gen. Train underscore data gen is basically what data augmentation techniques that we are applying on the training data set, and the test data gen is basically the generator for the test data set. Okay, so remember this, and this is where we are applying various augmentation techniques. The first one is rescaling. What is rescaling doing here is it is normalizing the data set. Since we know in an image data set of an RGB value, so there are R, G and B, that is that R stands for red, G stands for green, B stands for blue, and all of these have their own pixel values ranging from 0 to 255. Instead of 0 to 255, which occupies 8 bits of data, and it is a much larger data set in order to train your model, and thus your model training becomes slower. What we do is we divided the particular pixel value with the maximum value in order to get a value rate from 0 to 1, so that the training becomes faster and more efficient. The second data augmentation technique that we are using is zoom underscore range. So zoom underscore range is basically when we are zooming the image, and here 0.3 means it would be zooming into the image, 0.3 means it would be zooming minus 0.3 to plus 0.3. Okay, so this is the zoom range. And the vertical flip. Vertical flip means it is basically it is drawing a vertical line and it is flipping the image, that is the left becomes the right and the right becomes the left. In this particular image we cannot do horizontal flipping, because then the upper side of the chest would be down and vice versa, so it would not be depicting a correct data set. So these are the data augmentation techniques for a training data set. But in case of test, I am just keeping it a simple normalization, because I do not think so that somebody will zoom into the image and show. It will be just a normal he would be that in the testing data set, it would be just the image of the chest X-ray, and it would be just be normalized in order to make it more efficient. Okay, so trail underscore set is basically the images that we are getting while passing this train underscore data gen, while applying this train underscore data gen on the directory, that is train directory. The train directory contains all the images from the training data set. The target size is image underscore dims, image underscore dims, that is here we are specifying all of the images must be consistent size, that is image underscore dims. And as you can see below that we have provided the size of image underscore dims as 256. So this is our target size. The batch size is also specified here, and the class mode is binary, since there are two classes, that is Pneumonia and normal. So this is a binary class, and we would have to shuffle. Shuffle basically helps us randomize the data more. So this is how we have used train underscore data gen, and this particular method flow from directory basically takes in all of the images that are present in this particular directory, and it applies these augmentation techniques on that image while keeping these constraints in mind, that is image underscore dims, batch underscore size, the class mode, and shuffle. And at the end we get train underscore set, which contains multiple batches of images that would be generated from this particular directory and would be going through that particular augmentation techniques, that is train underscore data gen. Similarly we have done for validation set, and similarly we have done for test set. Also keep in mind, in this validation set as well as the test set, we have used the test underscore data gen because we just want it the model to be validated on normalized data set, that and not vertically flipped and other augmentation techniques, right? So this is what we have done for pre-processing the data, and in order to remove the biasness from pneumonia and normal, and in order to make our data much more consistent and random, and much more consistent in the size and much more random in the features, in order to train our model much more efficiently. So image underscore dims, we have specified it to be 256. In the previous iterations we have also tried various sizes like 512 and like 512 cross 512, 100 28 cross 128, but most of them we were not getting we were getting a varied data set results in both of them, and ultimately we have stuck to 256 cross 256 because the data because we are getting the best result in this particular size. This is the number of epochs. I will be explaining what epochs are and how they affect our training. The batch size is 32, and as I told you, what batch size means is basically it specifies the number of images that is we are not feeding the images all at once into the model while training the model, and we are training them batch wise. Okay, so here we have got all of our data sets, that is train underscore set, val underscore set, test underscore set. Now after completing the pre-processing of our data, the next work is the model architecture. Okay, now to explain you the model architecture, I would have to explain you what convolution neural network does and what does it comprise of. So what neural network does is it has a structure similar to a brain, and it has weights assigned to each and every neuron, and when an input is provided, it is able to generate a particular output on the basis of the weights and activation functions that are used. Okay, so this is how a basic neural network works. In case of convolution neural network, what happens is that before this neural network thing, it is this convolution neural network is especially good for image processing, image recognition. Okay, so any case of image prediction related to image, we can use convolution neural networks for a better result. What does convolution neural network do? It extracts features from a particular image, and after extracting each and every feature through layers, it passes it through the neural network, and then we are getting a particular output. So here convolution layer is basically that layer that extracts feature. Max pooling layer is used in order to reduce the size of the image, and so that the model trains much faster and in a much more efficient manner. Here another layer is used as a batch normalization. What batch normalization does is since these filters, these are the filter sizes, that is 3 cross 3, 3 cross 3, 32 is the number of filters in the first layer. Since these filters have values, what are filters? Filters are basically matrix, and the values inside the matrix are set randomly, and if some value becomes very large at comparison to other values, so it undergoes batch normalization in order to prevent that feature to be highlighted each and every time. So batch normalization is also used. After performing all these operations on the image, then we flatten it. Okay, the output of all the convolution layers are matrix, but in the end what we do, we flatten it and then we pass it through a neural network, through a dense neural network. The first dense neural network has 512 neurons. The second dense neural network has 256 neurons. The last one has one, which is basically predicting whether it is a pneumatic case or a non-pneumatic case, or the normal case, that is. All of them has an activation function of rectified linear unit, while as the last one has a activation function of sigmoid. And then we compile the particular model with an optimizer, that is Adam, and the loss is binary cross entropy. In a case where we have two categories, we have binary cross entropy, and the metrics, that is otherwise we have categorical cross entropy, and the metrics is accuracy. So this is the basic architecture of our model. First we have this is the summary of our model also. This is the first, we have a convolution layer, then we have a max pool layer, then we have a convolution layer, then we have a batch normalization layer, and so on. So this is particularly the architecture of our model, and then we train our model. Okay, so in the training of our model, we also use various callbacks such as LR underscore reduce. What LR underscore reduce is that it when the learning rate is too high, it becomes the graph that we get for the loss is becomes very uneven. Means it becomes like a mountain. Means the suddenly the validation loss may increase then fall, then increase then fall. That is not very expected from our model, and the model must be training in a smooth manner. So that is, the validation loss must always reduce in a gradual manner and not in a haphazard manner. Okay, so similarly for the validation accuracy as well. So that's why we use LR underscore reduce, so that in case of any plateau it is occurring, that is the validation accuracy, I guess we are applying it on validation underscore loss. So when the validation underscore loss is not decreasing, we reduce or it is increasing, then we perform LR reduce, that is the learning rate reduces. Okay, initially the learning rate is 0.01 and then it further decreases 0.001 and then it further decreases when a plateau is faced. We had initially used early stopping, but in this particular model we have not used early stopping as a callback. So this is our model training, where we have passed the training set, the steps per epoch, the epochs, the validation data, the validation steps, as well as the callbacks. So as after training we get this particular result. So as you can see that with each passing epoch, so what is epoch basically? Epoch is when suppose our model takes rounds in training. In the first round it has trained, it checks its output with the validation data or the validation set, and whatever its output is, whatever the loss it has got, that is known as the cost function. On the basis of the cost function, it back propagates and it changes the values of the filters as well as the weights of the neural network, and it again trains the model. This occurs in our case for 10 times. That is the epoch. One forward propagation and one backward propagation makes up an epoch. In this particular model we have done 10 epochs to train our model. So we have plotted the accuracy as well as the validation accuracy. As you can see, the accuracy is always high. I guess it is at here you can see the accuracy, that is, it is as 96%, whereas our validation accuracy is at 91.72%. It is fine. It is never actually meant to coincide, and if it is coinciding at a very early stage, that means your model is either overfitted or there is some discrepancy in your model. Okay, so this is what we have plotted. The validation accuracy versus the accuracy of our training, and this the yellow line suggests the validation accuracy, and as you can see, with each and every passing epoch our validation accuracy is increasing. First it was, I guess, 63, then it was 62, then it increased to 65, then it increased drastically to, I guess, 85, then it gradually increased to 91.75 was the last validation accuracy that we got, was the highest validation accuracy that we got. Then here is the graph for validation underscore loss and loss. So here what we have done is our model is training, as you can see that there was an initial spike, but then after that it was a gradual fall of the loss, and they are coinciding here. So we have reduced the loss of our model also, and then we are testing our data, and various metrics we have tested, like the precision, accuracy, recall, F1 score, and the training accuracy. So we are getting an accuracy of 90.544, that is almost a 91% accuracy. or you can say 90.5% accuracy, and the precision is 88.75. The recall is high. See, what does recall mean? Recall means that the number of pneumonia patients that we have predicted is actually pneumonia. Means we are not predicting anybody to be normal when they're actually pneumatic. So that we are getting as an accuracy of 97%. That is good, because then the patients are most likely to undergo a treatment. This is the training metric that we are getting as 96.53. And now we can see that we have our confusion matrix here. In the confusion matrix, the first cell signifies the true negative, this signifies the false positive, this signifies the false negative, this signifies the false positive. So as you can see, we are out of, I guess, suppose 200 patients, we can 220 patients, we can predict that 190 patients are normal, and around 50 patients are predicted, normal patients are predicted to be pneumatic and pneumonia. And as you can see, in this particular case, when we are predicting pneumonia, that is then we can say that if the particular person has pneumonia, then we are predicting it to be normal only 11 cases. Otherwise, we are predicting correct for the rest of the 380 cases. I guess the total number of cases are 390, and out of that 380 we are predicting it correct, and 10 we are predicting it wrong. So this is the result of our particular model that we have trained right now. And after this prediction, what we are doing, that we are using the keras.models to save our model in a particular file path. Then using google.colab, we are downloading this particular model. Okay, so after downloading this particular model, what we would do, that we would be using it as the model to predict our output. So this is the model. So in our particular Flask application, what we have done is that we have taken in this particular model and any input from the user. Suppose so the UI of our particular application is this, where this is the index page. So on clicking on when a particular user hits this particular URL, then he is greeted with this particular page where he has a choose button, where on clicking on choose he can select a particular image. Okay, on selecting a particular image, it is previewed and a button called predict is given. Okay, see, a button called predict is given. On clicking on predict, what happens is that this particular image is taken in as a file. This is saved in as a file here. It is saved in a folder that is uploads, and then it is passed through a function that is model_predict, where we are passing the file path as well as the model that we have downloaded from our Google Colab. So this is the model that we have downloaded, and we are passing it as a parameter here. So this is the image path and the model. So what happens in the model_predict is that since we have trained our model to only predict from images that are 256 cross 256, so first we have to for any type of image or for any dimensions of image, we have to reduce the size to, or we have to increase the size to 256 cross 256, and we have to normalize the image. So first what we have done, we have normalized the image. Then we have resized the image into image_dims, image_dims, comma 3 signifies the RGB, and then this particular image is passed through the model, and we have to predict the result. What preds have is an array of results. Means since we are passing only one image, so there would be only one element in this particular array. So in this preds, we are returning the preds from our model_predict function. Okay. So what model underscore predict function does is it takes in the first value, that is the preds value from the particular returned value. So preds is returned from a model underscore predict function, and we are taking the value and then we are rounding it. So what does preds return? Preds returns is a probability of is a value ranging from 0 to 1 that signifies the probability whether a chest x-ray scan is pneumatic or not. So more the value towards 1, that is suppose 0.75, 0.8, 0.6, they have a chance of contracting pneumonia. Otherwise, if you have a value from 0 to 0.5, then you are considered to be the chest x-ray is considered to be a normal one. So what we have done is we have rounded our particular probability, and if it comes to 1, then we predict that it is a pneumonia case. Otherwise we predict that it is a normal case. Then we have done os.remove file path that basically removes that particular image from the system. So on clicking on predict, so let's choose an image. As you can see that first I've taken the test directory and I'm choosing an image directly from here, and we are predicting the image. So this is, we are getting a result as a normal case. And otherwise what if we select another image from the test, that is pneumonia, and we click on predict, then we get a result as this is a pneumonia case. So as you can see that on feeding on different types of image in our web application, we are getting different results. So we are getting the correct result. So in this particular web application, we have successfully solved the problem where any type of image can be uploaded of any format of any size, and that could be and our model or our application could be used to predict whether that particular chest x-ray scan is pneumatic or not. And this would be very helpful in order to confirm your results, that is if you have a chest x-ray from your doctor has said that you have a normal it is normal case and you do not have a pneumonia, then you can upload this particular image and check whether confirm whether the doctor is saying right or not. Or even doctors can use it in order to confirm whether they are getting the result that they have predicted is correct or not. So this UI is very simple. As you can see that just a choose button there where you can choose a particular image, and a predict button where you can just predict that the result. Okay, so this is basically a normal UI, and this is the project that we have developed.